Hello friends, today I'll be looking at how to differentiate composite logarithmic functions. With logarithmic functions, I mean natural logarithm, because this is lane. The first question says lane, x squared minus 3x plus 1. Natural logarithm, I call it lane. Now, the second question says lane sine x over 2. So what I need to do, I'm going to recall this. For me to differentiate this, I'm going to recall that if this function is given as ln x, if you want to find the derivative of this, the derivative is going to be dy over dx. The derivative of ln x will give you inverse of x. So for me to differentiate this expression, okay, I'm going to use composite law for composite function. Okay, then I'm going to call this x squared minus 3x plus 1 a letter u. Okay, so calling it a letter u is going to be u is equal to x squared minus 3x plus 1. Then that means from this expression, y becomes ln u. So that is replacing x squared minus 3x plus 1 with u. So y becomes this. The goal is to achieve something similar to this. Because whenever you want to differentiate ln of a variable, it becomes the inverse of the variable. So the goal is just to achieve this. So I'm going to apply, for me to get the answer, I'm going to apply law of composite function. So, and the law, you know that the law says dy over the x is equal to du over the x times dy over du. That's the law, depending on how many functions you have. So what I need to do is to differentiate u with respect to x and also differentiate y with respect to u and multiply. That will give me the value of the y over the x. So doing that for the first expression, I'm going to write du over the x. Then I will use the general formula for differentiation, which is n a x raised to the power of n minus 1. I'm going to use this formula to differentiate this algebraic expression, that is quadratic algebraic expression. Now, this is going to be differentiating the first term x squared using this formula. You know, n is the power of the variable too. So I'm going to, it's going to be, and you know, a is the coefficient of x squared here. So this is going to be, differentiating x squared is going to be 2x. Okay, then minus, I'm going to differentiate minus 3x. That will give me minus 3. Then differentiating quadratic constants in differentiation is going to be 0. So this is going to be 0. 2x minus 3 is going to be 0. So that is the derivative of u here. So derivative of y here is going to be dy over du. That is this against this. So, and remember this, I said, when you have this function, so the derivative is going to be inverse of the variable. So derivative of ln u is going to give me 1 over u. So now I got 1 over u. For me to get the value of the y dx, I'm going to apply this rule, this fraction rule of composite function. So that will give me dy over the x will be equal to, I'm going to multiply 2x minus 3 multiplied by 1 over u. That is the u over the x, which is 2x minus 3 times by dy over the u, which is 1 over u. So this is going to be 2x minus 3 is going to be 2x minus 3 divided by, remember the value of u is what? The value of u is x squared minus 3x plus 1. So So that is x squared minus 3x plus 1. So this becomes the answer as dy over dx. Okay, it's very simple. Now I'm going to do the same thing in this second expression, second question, which says len bracket open sine x over 2 bracket close. Well, the question is I should differentiate with respect to x. Now what I need to do here is to break this thing down. Okay, I can call theta x over 2. I can call sine, that because replacing x over 2 with theta, that is becomes sine theta. So now I can call you that sine theta. That is sine theta. Then I can now call y, that is the whole function, len u, because I'm going to replace the whole of this with u. That will give me len u. The goal is to achieve this. Okay, now for me to differentiate, I'm going to still use this composite function law to multiply out. Now before I do that, I'm going to find the theta over the x, that is differentiating theta with respect to x, and I'll differentiate u with respect to theta, and also differentiate y with respect to u. So that is going to give me, doing that, I'm going to have the theta over the x, that will be equal to, then that will be equal to differentiating this. You know that this is the same thing as half times x. So when I differentiate this, it's going to give me half, using our general formula here. When I differentiate, it's going to give me half. So I'm going to differentiate u with respect to theta, du d theta. That is going to give me, when you are differentiating sine theta, you are getting cos theta. Okay, so I'm going to differentiate y with respect to u. Differentiating y with respect to u, that is dy over the u. That is give me 1 inverse of u, that is 1 over u. Okay, just like here, what I said here. Now I'm going to multiply out this 3, this times this times this. That will give me dy over the x, because if you multiply out, the u will cancel the u, the theta will cancel the theta, so you remain dy over the x. So that is going to give me dy over the x is equal to half times cos theta times 1 over u. So this is what it's going to be. Okay, now I'm going to have this, which is equal to 1 times cos theta times 1 is going to give me cos theta, okay, divided by, this is, if you do this over 1, it's going to be 2 times 1 times u, 2 times 1 times u is going to give me 2u. Then dy over the u over the x is equal to cos theta over 2u. Remember that 2u is given as sine theta. So I'm going to write cos theta divided by 2 sine theta, because sine theta is represented by u. So this is, but you know that from this expression that theta is x over 2. So I'm going to write cos x over 2, replacing theta with s over 2, divided by 2 sine theta. I'm going to replace theta here with x over 2 sine x over 2. Now, looking at this expression, I can say simplify because this is cos over sine. Cos over sine, they have the same x over 2, x over 2. Cos over sine. In trigonometry, cos over sine is the same thing as cot, because you know sine over cos is the same thing as tan. So that means inverse of tan is cot. So what I need to do, because, and you know that this is over 2, 1 over 2. So I'm going to write, therefore, in order to simplify further, therefore, dy over dx will be equal to half cot x over 2, because they have the same angle, x over 2, x over 2, and cos over sine is the same thing as cot. So even if you leave the answer like this, it is still correct, but to make it simpler, this is the final answer. Thank you for watching. Don't forget to subscribe to this channel.